You know, every single day, your brain is playing detective, solving dozens, maybe hundreds of tiny mysteries you don't even notice. We call this whole process logical reasoning, and it's basically a set of amazing tools you're using constantly. So today, let's open up that toolkit and see what's inside. Okay, let's start with a really simple mystery. You look outside, and the grass is wet. So why? I mean, immediately your brain starts firing off ideas, right? Did it rain? Did the sprinklers go on? Maybe the neighbor's dog paid a visit? See what I mean? Without even trying, your mind is already on the case, just generating all these possibilities.
And that automatic problem solving, that's exactly what we're going to break down right now. We're going to unpack the three fundamental tools of reasoning that turn all of us from just passive observers into active thinkers. I think the best way to picture this is to imagine a detective's toolkit. You wouldn't use a magnifying glass to break down a door, would you? Of course not. And in the very same way, your brain has a specific logical tool for every kind of clue and every type of problem it runs into. So first up, we've got the Sherlock Holmes of our toolkit, deductive reasoning. This is the logic of absolute certainty, of drawing conclusions that are pretty much undeniable. It's precise, it's powerful, and it all works by applying a big, general rule to a very specific case. So deductive reasoning is what we call a top-down process. You start with a big general rule that you already know is true, and if that starting point, what we call the premise, is solid, then your conclusion is absolutely guaranteed. It's kind of like a logical waterfall. It can only flow one way, from the general down to the specific. All right, let's put this tool to the test with a classic logic puzzle. Here is the one and only rule you need to know. If a card has an even number, it has a vowel on the other side. Got that? Even number on one side means there must be a vowel on the other. Okay, so here are four cards sitting on the table. We've got a 6, a V, a 5, and an A. Now, to prove our rule is 100% true, which cards do you absolutely have to turn over? Take a second, think like a detective. Which ones are essential to cracking this case? So what's the answer? You have to turn over the 6 and the V. Here's the logic. You flip the 6, an even number, to make sure it has a vowel on the back. Simple enough. But here's the tricky part that gets a lot of people. You must also flip the V. Why? Because you have to check if it has an even number on its back. If it did, you'd have an even number with a consonant, which would completely break our rule. The 5 and the A, they're irrelevant, because the rule says nothing about odd numbers or what's behind a vowel. That right there is pure deductive logic. And this isn't just for fun little puzzles. Scientists use this all the time. They start with a huge theory, like all life needing water, then they narrow it down to something specific and testable, collect their data, and see if the evidence actually holds up. It's a really systematic way of proving what we think we know. Okay, so deduction is fantastic for testing a rule that we already have. But where do we get those rules in the first place? Well, that's where our next tool comes in, inductive reasoning. This is the tool of the explorer, the one we use to create a brand new rule based on what we see out in the world. What's really cool here is that the direction is flipped. Unlike deduction, inductive reasoning is bottom-up. You start with little specific clues and you build your way up to a much broader theory. But you've got to notice the key word here, probable. Your conclusions are likely for sure, but they're never, ever guaranteed. Let's make this super simple. Imagine you've got a bag full of coins. You reach in without looking, pull one out. It's a penny. Okay, you do it again. Another penny. And a third time, yep, also a penny. So, based on just that specific evidence, what would you start to think about all the other coins that are still in that bag? What's your working theory at this point? You'd probably make what we call an inductive leap and guess, hey, all the coins in this bag must be pennies. And that's a perfectly logical hypothesis based on your observations. But, and this is a huge but, it's not certain. The very next coin you pull out could be a quarter, and poof, your whole theory is instantly wrong. That's both the power and the peril of inductive reasoning. In the world of research, this is literally how new theories are born. You notice something specific, like, hey, my flight's delayed. Then you look for a pattern. Wow, a lot of these specific kinds of flights are delayed. And from that, you develop a general theory. This is the very starting point for scientific discovery. All right, time for our third and final tool, abductive reasoning. If deduction is Sherlock Holmes, this is the logic of an ER doctor or a crime scene investigator. It's the tool you grab when you don't have all the facts and you have to make the most plausible explanation you can. The whole key here is that abduction is all about making an educated guess. You're working with an incomplete picture, you've got gaps in your knowledge, so you infer the most likely cause. This isn't about finding absolute proof, it's about figuring out what's most plausible. Here's a perfect everyday example. You walk in the door after work and there is shredded paper all over your living room. The only other creature in the house is your dog. So, what's your first thought? The dog did it! I mean, could a burglar have broken in just to shred some junk mail and then leave? Maybe, but it's not the likeliest scenario, is it? Your brain abductively jumps straight to the most plausible explanation. Okay, so we've looked at the 3 main tools in our logical toolkit. Now let's lay them all out on the workbench and see how they compare side by side. This is where it's all going to click into place. And this table just pulls it all together so nicely. Look at deductive. It's top-down, starting with a big roll to test a theory, and it gives you certainty. Then you have inductive. It's the exact opposite. It's bottom-up, using little observations to develop a theory, which gives you probability. And finally, abductive reasoning kind of stands on its own. It's not about direction. It's about inference, just finding the best, most plausible explanation with whatever data you have. 3 totally different tools for 3 totally different jobs. This quote really nails the beautiful partnership between our first 2 tools. You use induction to build the ladder of a new idea, and then you use deduction to climb up that ladder and make sure every single rung is solid. Science, and frankly, just clear thinking, really needs both of them to move forward. All right, one last quick puzzle to really lock this all in. Let's use our deductive tool. Premise 1, Gulag is a Martian. Premise 2, all Martians have red tongues. So, what conclusion can you draw that is absolutely 100% certain? Exactly. If those first 2 statements are true, then the conclusion that Gulag has a red tongue is totally unavoidable. That's the airtight, inescapable logic of deduction. So there you have it, the detective's toolkit that your brain is using all the time. Deduction, induction, and abduction. Together, they're how you solve problems, form beliefs, and just make sense of reality. So the only question left is, now that you can actually see the tools you're working with, how are you going to consciously use them to build a clearer, more logical understanding of your world?